Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you missed any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we will try to get to as many as we can near the end of today's webinar. Also happening during the webinar, we will have 3 polling questions. So hopefully we can get everybody engaged. And at the end of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Digital Transformation in a Kubernetes World. Our speakers today are Blake Jackson, who's a senior architect at RTS Labs, and Justin Boutwell, who is senior software engineer at RTS Labs. Guys, thanks so much for joining me today. Really appreciate it.
Hey, thanks for having us. Thank you.
Awesome, awesome. All right, well, I know you guys have a great webinar on tap, so I'm going to take myself off camera, put myself on mute, and I'll be back for the first polling question.
Great, thanks. Yeah, to get us started, I mean, we're here to talk about a digital transformation in Kubernetes world, as the title suggests, and to really talk about the impact that DevOps has on the rest of the organization, how it plays on to the digital transformation, and ultimately we're going to talk a lot about Kubernetes and a lot of different things. So hopefully we have something enjoyable for everyone in store. I am Justin Boutwell, and I am here with Blake Jackson, and we will both be speaking on today's topic. We are both engineers and architects for RTS Labs. RTS Labs is a consultant company that works with companies of all sizes, from startup to enterprises. And we do everything from build custom software to helping organizations better organize around some of the principles we'll be talking about today. And a lot of what we'll be talking about is based off the experience that we both have working with these organizations, the learnings we take away from that. And in a lot of ways, the opinions we've formed about a good way to run IT and engineering when it comes to software development, and then ultimately how to get there. So specifically around today's topics, what we want to go through are to first start about with why we are here, to lay the groundwork to make sure we all agree that this is an important topic. So then lay a business case for it. So everything, particularly when we talk about the kinds of high-level decisions that we will be focusing on here around, as implied in the slide, DevOps, Microservices, Kubernetes, the business really needs to be involved because these things are ultimately done in order to move the business forward. So why should they care? Why should they invest? How can we convince them if that convincing is necessary? We'll move into a high-level solution, ultimately display what is the end goal that we want to get to, that will hopefully paint the picture of why we think microservices and Kubernetes are important in this particular vision, and then tying all that together after going over each one of the major components individually. So to get us started, why are we here? I think it's probably true for a lot of us through experience that IT is having trouble keeping up with the demands of the business for many businesses. I mean, as a consultancy company, we, naturally we have people coming to us with their problems, and their problems are very similar across the board, which is, in a lot of ways, there's a lot of companies who didn't start as IT companies, but they're becoming IT and IT more naturally as things move more online, as systems become more complicated, and their competitors are starting to either to automate or to digitize themselves, and they need to both keep up and they want to move forward and ahead of them. And I think, we're all, this is a DevOps webinar. I think everyone here is in some agreement, likely, that DevOps is a good foundation for how to get that done. But DevOps has a few implications on what actually needs to happen in order to achieve sort of the vision of DevOps. I mean, DevOps itself really puts a lot more expectation on the engineering team. We're really requesting teams to do more with automation, to make sure everything they do communicates with each other. I mean, that's the point of continuous integration. To really create a seamless a product of products, right? We want the machine that builds the machine, and that in itself needs building. That's putting more expectation on the engineering teams. And to succeed, we really require a set of tools that whose strength is automation. We need the process to sort of enable and empower those tools. And an implication of all those is we need an architecture that supports the ability to make the kind of progress and to reach the velocity that we want in terms of changes over time. And the architecture is probably the more elusive of the one, or at least the one less likely to be talked about. I mean, a big tenet we'll get into of DevOps is automation. That's pretty clear. But as teams and projects grow, you need the architecture to be able to support that, or you're just going to run into a bottlenecks at different points within the problem. So if we agree this is the problem statement, the IT can't keep up, and we need to be able to keep up. Where do we go from there? So we want to start with a business case, but before we jump into the business case, I have a polling question.
All right, the first polling question should be up on your screen. The polling question is, if you could choose one thing to improve, what would it be? You can select from speed to market, operations cost, flexibility, or reliability. Go ahead and make your choice. And while we are waiting for everybody to make their choice, just a quick reminder, if you have a question for either of our speakers, you do not have to wait for the question and answer period. Please go ahead and use your GoToWebinar control panel at any time during the presentation and submit your question. And we'll try to get to as many as we can near the end of the webinar. So looks like we are getting pretty well uptake with folks who are answering the polling question, but I'm going to go ahead and leave it open for about 5 more seconds, and then you can go ahead and quickly get your choice in. All right, we're going to close it down now in 3, 2, 1. All right, here are the results. If you could choose one thing to improve, what would it be? Looks like the majority, we have a tie for 1 for the first place, speed to market and reliability, which makes a whole lot of sense, guys. What do you think?
Yeah, I agree. I would have expected those two as well. Maybe for speed to market to edge out the two. But I mean, if there's anything, as engineers, the thing that affects our lives the most, the questions that we're all used to getting are, when can I have this done, which is naturally speed to market, and why is this broken, which is obviously reliability. And those are actually they might seem disparate, but they are exactly the same problem, which is in both cases, in all likelihood, we need to make some change and make it quickly. Reliability is a little more than that. We'd like to get ahead of the problem itself, and there's a lot of ways to do that. But at the end of the day, we need to identify change, make it, and then push it. And it's amazing with a lot of the companies we work with how hard that is to do, in what seems like such a simple statement. So yeah, I think this naturally, if you can flip back to the presentation, moves really well into I think the first and principal slide of the presentation, which may be good. I think we're back in. Everyone should see me now.
Yep, you're good.
What is really, to start at the beginning, what is ultimately the objective of the business, right? The business itself is really to increase revenue and margins and to grow over time. I mean, this seems obvious, but that is the focus of any business, and that focus is ultimately derived from, or subsequently focuses on customer satisfaction in order to get there. And just a true matter of fact is that a lot of customer experiences are moving more and more into the software domain. And so across the business itself. So whether that's in retail, whether that's banks with internal applications, or healthcare and the way they interact with their patients, it doesn't really matter. Most of this is moving more into the software engineer's problem domain in order to achieve better customer satisfaction. And the way that IT can move this forward is by effectively affecting those 4 points from the polling question itself, right? We need to do all of these things. We need to move faster, we need to be more reliable, and we need the things we produce to be easier to use, in a lot of ways a proxy for reliability. And then we also want to be able to innovate and actually get innovation out the door. I've seen so many cases where the innovation is there conceptually, we all have the ideas, but actually producing that and seeing that in production and seeing it realized is a real struggle, and that's the thing we're looking to solve. So if really what we're talking about here is we need to improve customer satisfaction by improving these metrics, What are some of the counter sides of this? What is it our experience in IT tell us that we need to work around in order to get there? One, which I personally see as a failing in a lot of organizations that they don't seem to recognize well, is that until something's in production, it has zero value. So you can have the most incredible ideas. You can be working along a path that feels like it's going, it's going somewhere, that we're going to have something that the customer really likes, that we're improving our system's reliability. But ultimately, until that thing is in front of people, it has zero ROI. Another just fact of IT is, as we know, is requirements constantly change. This almost doesn't matter about how much requirements gathering are doing, how much time we spend thinking about it. The environment changes. I mean, hell, the way the world is right now, we all know that. The environment changes regularly, and we need to be able to react to it. Requirements change because the customers don't know what they want, and what the customer wants changes. And then just the fact that we need to constantly compare ourselves to our competitors and against what the customers see as worthwhile means we're constantly shifting directions. And if we reach a slow enough point where we're not getting things out into production, we can change quicker than we're releasing. And we all end up in this point where we feel like we're either getting nothing done, or what we're getting done is already behind schedule, and that we can never possibly keep up. So this sort of translates itself into, okay, well, how does IT need to go about solving it? This moves more into the direction of what we think of as what DevOps is traditionally trying to solve. We need to be more productive. What does that productivity mean? How do we get there? We want to release more often. Productivity is we can achieve productivity by reducing redundant work and reducing low value work, automating. We'll talk a little bit more about that. We don't want to waste time on resolving production issues. We want to focus on uptime and responsiveness, time to recovery. Effectively, we want to get rid of all the unplanned work that comes with things like downtime, unplanned work that we might think of as planned, all the manual stuff that we're doing on a regular day-to-day basis. It's usually really not planned. That's costing us more time than we think. And we just ultimately want to become more productive. And then within that, we want, as the teams and software complexity grows, we want it to continue to work for that. And not just work, for our current problems today, but going forward. Moving down the line, the last slide within the business case section is that these all naturally then flow into, okay, well, if I want to be more productive as a team, then how do I, what kind of structures are ultimately enable that productivity? One of my favorite laws is Conway's law. It's probably a big reason why we think of DevOps as a way of organizing teams and reorganizing the organization, because Conway's law says that ultimately the software that we are building, the way the software interacts, the way it's managed, ultimately looks like the organization itself. And so we want to be cognizant of that. How do we organize around that so that the outcome of the software itself is desirable? And then further down the line, the architecture itself should work for the best. There's some functions of the architecture we want. These are, I would again also argue, are knowns. We want to have an extensible architecture. We want to be able to compose these things, these services and applications, in a way that feels seamless, that works for customers. And customers doesn't just mean the external parties who are maybe paying for our services. That can be our own internal teams and everyone else involved. But we want these things to be coupled in a way that we can make changes without fear of breaking and bringing the whole thing down, where the minor code fix is now set one fault and everyone's freaking out. So we want to be able to build an architecture around this and have tooling around this to really support the process. So what is a solution? What is a solution that ultimately we're prescribing that we think helps solve this? But before we get into that, we have our next polling question.
Okay, the second polling question should be up on your screen now. Where are you in your digital transformation journey? You can choose from, we're just thinking about implementing DevOps practices. We've implemented DevOps and looking ahead to microservices. We have microservices, but we need a new orchestration system. We are testing Kubernetes in a development environment. Or what is DevOps? I sure hope that nobody chooses the last one. All right, guys, I'm going to give you about 15 more seconds, and a quick reminder that today's event is being recorded, so you will have the opportunity to access it later on demand if you want to watch it again. And we'll be sending out the information regarding that. So I'll be letting you know at the end of the webinar how to access it then. Okay, guys, I'm going to go ahead and shut this down in 5, 4, 3, 2, 1. All right, looks like the majority of folks have implemented DevOps and are looking ahead to microservices. Oh, nope, I'm sorry. They're just thinking about implementing DevOps practices, followed by we've implemented DevOps. So looks like people are down the path.
Yeah, this is interesting. I mean, it's pretty typical. There's a mix. And obviously, you know, if this is a court of law, I'd be accused of asking leading questions when it comes to microservices Kubernetes. But I mean, it makes a great deal of sense. And I mean, a lot of what, you know, we're trying to do here, I'd say today, is make the business case for DevOps and a lot of the subsequent choices in order to hopefully give firepower to people who maybe feel a little hopeless in terms of how do I really sell this within the organization, and you know, does this really work? You know, and to help make choices. There's so many options. There's so many ways to go about, you know, organizing a business in IT. You know, sometimes it's just helpful to see opinions and examples of success. So great. Hopefully we'll cover something for everyone. I think we will. Hell, there's even a slight slide on what is DevOps, but you know, we'll get through that very quickly.
Well, I'm really glad that nobody chose that. That's all I have to say about it.
Great. So really, what that question is related to the fact that kind of want to go over the next two slides are here to paint a picture at where we think when we look at a lot of companies and their IT organizations, they fit into a very similar structure. Which is a structure that looks very much like a traditional assembly line, where traditional organizations, you know, where teams are organized around expertise, and expertise is effectively siloed from each other, and work is passed between expertise along a process in order to get something from idea production. So it's not very uncommon for, say, I know, some new feature work to be added to the queue of things that need to get done for this particular sprint or month. Developers pick that up and build it. Once on completion of building it, it gets handed off to QA by some means. That could mean running it in a QA environment, and the QAers go and test that, or it could be a little more sophisticated than that. QAers test it, they approve it, disapprove it, it moves back and forth until that's complete. And then some operations group is ultimately then responsible for deploying it. And I think this, if you think of it from the assembly line perspective, it makes sense in some sense where, you know, you're focusing expertise within specific domains. It's hard as an individual, even as someone who's done, you know, development now for quite a few many years, that just the knowledge it takes to be able to do testing and development and operations well is quite a bit. It takes quite a bit to get there. But I think where this breaks down and why this starts to, you know, where this goes awry is that software development is not like a traditional assembly line. Work does not move in one direction, and it is never clear exactly when the handoff should happen and if we've even prepped for the handoff at all. So for example, I mean, developers, most of the time, testability is directly related to how well something's been developed for that testing. And so there's some inherent requirements in terms of the software built itself in order to make it testing and testable. And that's the same thing that's true for operations. It's different. It means something different to deploy a jar that's been built locally than it means to deploy a Docker image off into some, you know, Kubernetes or some other cluster. And so those requirements are, you know, affect each other. And so there's quite a bit of back and forth. Those back and forth is ultimately means handoff and lost time and negotiation. And we see a lot is that you introduce managers to help manage these problems. And the more managers you add, you see you're not ultimately adding any more manpower to the actual work to get done. So and then that tends to slow it down itself. So this is sort of a self-defeating problem. The application, if you looked at the picture in general, you also tend to see this with more monolithic or sometimes more, you know, SOA-based application structures where there's larger code bases that the teams are focused on, and there becomes problems within that regard too. What happens when there's several changes that need to be made to the same monolith? That's just a thing that has to get managed, and is a difficult thing to manage within itself. And so the converse picture that DevOps paints in that that we're going to try to take a little further, and we'll just see that in the next slide, is a sort of full ownership model that's promised by DevOps. So DevOps has several core tenets which we'll get to. But it's ultimately about organizing teams in a way that that each team is capable of doing everything from idea to production, such that you could give a particular task to a team, they will build it, test it, and deploy it. There are natural benefits of that, which are there are fewer handoffs, there's less negotiation between people, less meetings, all the things that fall out from that. Increased accountability. If I am responsible for testing and deploying my own code, if I'm up Friday night monitoring this stuff and I'm suffering from it, I will be pretty motivated Monday morning to not have to repeat that again. And that might seem minor, but if it's an operations team that's responsible for it, it's not necessarily me feeling the pain. And I don't have that same level of commitment per se and shared victory. So a lot of it is around organizing teams, but if the picture itself is intentionally different than the previous one, which is ideally these teams are working on systems themselves that handle the fact that they are working independently on independent parts of a system. If we were to keep this structure while working on a monolith, that could work, but we're going to run into the same kinds of problems and bottlenecks at just different points of the application development process. We're making 5 separate changes to one of 1,000 class files in the same massive service. Which ones are ready to go? How do these changes affect each other? If we're using a branching strategy when the merging occurs, where are we and when becomes a hard problem. It's a solvable problem. I'm not saying this is, we're not really saying here that change to that architecture is absolutely required, but it naturally becomes a change that we think should be made in order to help facilitate the team organization. And so to break that picture out bigger and ultimately to get to all right, so why are Kubernetes and microservices, why are we prescribing that as sort of a part of the problem, a big part of the solution, is because as DevOps is sort of describing the people, microservices and Kubernetes describes the same thing, but for the architecture and for the tool set. Right, so microservices, and we have a few slides sort of dedicated to each one of these sections. So we'll first go through DevOps briefly, because I think we're all more or less aware of what that represents. Then we'll get into microservices and then Kubernetes. But how do these all tie back to the same picture? What do we really mean by them? And so why would going sort of all in, as one might say, and to such arguably complex architecture and set of tools, how will that get us to where we want to go? So first, we're doing a sort of a quick jump into DevOps, and really this is just meant to level set the conversation. I think we all hopefully understand what DevOps is promising to us, or outcomes we can potentially achieve. When we talk to companies about DevOps, we certainly focus mostly on the cultural side of DevOps. DevOps is about people, and so what you can find, in particular in lots of organizations, is a heavy sense of control, and you can argue that control as micromanagement. And what we think works best and seen work best is that if you give people trust and give people and teams independence, some direction, and I think some direction is what we want to look for architecture and tools. But if you give them that ability and that power, they will naturally take on the accountability and responsibility for solving problems. I mean, engineers are good and want to solve problems, and if we give them the ability to do so, then the outcomes of that tend to be natural. We want collaboration amongst the individuals on teams. If we cross-pollinate the knowledge of development, testing, operations, as the picture is ultimately trying to show, then over time you're going to have certain learnings that feed into each other. And there's more than development, QA and ops. There's design, and there's project managers, and there's all sorts of people involved that might encapsulate a team. But as sort of the traditional picture, I think this is a good one. And then the most software-oriented, I'd say, side of DevOps is around automation as a key tenet. And so if we're saying we want to give people independence and trust, one of the requirements we're saying is, all right, well, with this independence, the one major requirement is we want you to automate. So when we get into and so if we say that automation is a major tenet, what we're really talking about is tools, process, and then we'll get into design side of it in a little bit about how those, how to enable that DevOps through those things. I mean, tools are pretty clear. Not every tool can be automated in sufficiently the same way. Blake particularly will talk later around the complexity and size of the tool chain and everything that has to be considered, but not every tool is ultimately equal. And process is the same way. We want enough process to get the work done and to make sure that we're tracked against some common goal, and we're marching in the same direction, but too much process leads us down the same negative path of where we're at often not now, which is spending times in meetings thinking about problems instead of solving them, and so on and so forth. But leading into sort of the microservices side of the conversation, is design is ultimately a natural outcome of these things as well, because as we've stated, if we're talking about automating deployments, for example, which is one thing we'd be automating if we're automating everything, then it means something very different to automate one monolith across teams than it might be to automate service deployments within, say, a distributed architecture, and using using the tools that help you enable to do that, like Kubernetes. And so, stepping forward, we'll get into sort of the microservices side of it. So first, I think an important question of what are microservices. I'm not going to dwell too long here. And the picture painted is against the monolith. And I realize there's probably a lot of software that we've developed which follows more of a SOA pattern, but they're both ultimately struggle along the same points, which is that a monolith itself is ultimately one massive code base. Granted, it could be fractured more than that, but one massive code base that's serving some application or applications to serve all the customer needs and experiences through it. It's a single chain from the inbound traffic to the backend services to the data layer, and all of those things are sort of running in conjunction together within the same process. Microservices, conversely, has a few major key components. Services, so it's ultimately about breaking up the backend services into small components. Those services themselves must be well bounded, meaning it's very important to consider the contract of those services, because the only way in which the outside world talks to that particular service or its data is through its API, or maybe through dump pipes, through some form of JMS or Kafka or something like that. And that well bounded refers to the data itself. So, and this is probably its biggest distinction from many other architectures, which is if I have a service, say, that is the customer service, and that service serves all customer specific data, customer preferences, it might have a database, let's say a relational Postgres database that stores that data. There is no one who's allowed access to that database. Everyone who wants access to that data has to go through the service. This creates some complexity, but the actual outcome of that particular architecture is that if I ever have to change the database itself, I don't have to worry about it, conflicting with other changes to other services data, or other services being impacted themselves, which naturally starts to fit into sort of the DevOps model. Well, I want to be able to if DevOps is allowing me to make more changes faster, those changes themselves need to be particularly reliable, and I need to make sure those changes are isolated. But the microservices is giving you a particular structure that is in of itself isolated. Now, you don't have to go all the way to microservices to achieve this. There are lots of design patterns within microservices that you can apply even to the monolith itself. It's much hard, like microservices requires it. Once you start to communicate over REST, for example, as is often done, there is an obvious boundary, and you have to, that REST boundary is just respected inherently. Whereas within a monolith, you might say I have a class structure, two class structures that follow the same pattern, but over time, different engineers start to violate that. You can apply all these practices backwards, but microservices helps to enforce that. So then sort of the why question, on top of that, that's sort of first reasoning, which is as you're breaking something into smaller pieces, you have actually smaller things to work on. You're also giving yourself the ability to scale across all three axes of sort of the graph of scalability. And that graph breaks down into three axes, which are duplication, decomposition, and partitioning. Duplication can be done with affect almost any application, assuming you can run multiple copies of it and it not conflict within itself, which is not a given. But if you had a monolith, for example, you just run it twice, you run two copies of it and have a load balancer split traffic, right? You'd be duplicating it. Decomposition is the act of breaking that apart and saying, well, instead of one big application, that'll be 5 components. And that decomposition allows us to scale any one of those 5 components differently. And the partitioning is doing that just at the data level. So, for example, you can decompose in a SOA application, which has a bunch of services that are receiving traffic from different parts of some customer application, but they're also ultimately talking to the same data structure that's intertwined and intertangled, and that in itself becomes a bottleneck. Well, that partitioning then gives you scale across sort of the data layer. And that's sort of the last point around feature velocity, just harkens back to, well, these all then create smaller things and smaller surface area, which naturally reduces risk when making changes and all sorts of properties. I'd be remiss not to point out the fact that this comes with a lot of challenges, and those challenges need to be addressed before you would commit to something like this. Now, the thing is, this is, I think, what makes microservices the scariest and hard to commit to, but it's actually where I think Kubernetes and the kind of tooling we'll be talking about next really comes into play, because these are a lot of really hard problems, and these are actually problems that you should probably be solving even if you're building a monolith, that you should probably be centralizing your logs and doing well with tracing and understanding your network and all that stuff. But it's no longer an option in microservices, because networks will fail. It's a guaranteed to happen, I promise. There will be latency at times and spikes. When there's logs across hundreds or thousands of services, it's just impossible to SSH up to a box and look at logs. You can do it, but it's untenable. So you need to be able to solve these problems. And as scary as these are, they are helped solved by all the rich set of tools, and particularly with Kubernetes, just the power of the ability to leverage all the work of the community to be able to help with these problems. So so we're going to get into talking about Kubernetes, and that is where I'm going to transition to Blake to dive into that.
Great, thanks, Justin. So I think first off, let's start with what is Kubernetes. Kubernetes is a container orchestrator responsible for running your containers in the infrastructure, and it's intended to abstract away the infrastructure from end users, meaning that we don't really care if we're running on a VM, bare metal, whatnot. So before we move on any further, we have one more polling question.
Yeah, we're going to go ahead and launch it right now. What is driving you to Kubernetes? You can select from all the cool kids are doing it. We're already containerized and need a better orchestration. We're hitting the limitations of our current infrastructure. We need to modernize our systems, or my father was a sailor. That was a good one. I like that one. All right, guys, go ahead and make your choice. I love these little Easter eggs throughout the polling questions. They're pretty amazing. Quick reminder that if you have a question for our speakers, you can go ahead and use your GoToWebinar control panel and submit your question anytime. And hopefully we will have plenty of time for question and answer period and get your questions answered. Okay, about 10 more seconds, and then I'm going to go ahead and close out the polling question. We'll take a look at the results. And already I'm chuckling at some of the results here, but I'm going to go ahead and close them out here in 3, 2, 1. Here are the results. Apparently we have some sailors in the audience, or kids of sailors, and all the cool kids are doing it. So yeah, I mean, obviously those are not high ranking, but actually that kind of brings up a question that I had is, I mean, do you think people are using Kubernetes because everybody else is doing it, so why can't we, basically?
Yeah, I mean, there's probably always the fear of missing out, that people, maybe don't quite understand why they would need it, but again, see an article or a webinar and think, okay, yeah, we better get on it.
Yeah, but there's a reason for that, which is a good reason, which is everyone's doing it for a reason, and it still might not be for you or your particular problem. But the more something gets used, it starts to beg the question if there's a reason why that's occurring.
Yeah, that automobile really started getting used a lot when people were using horse and buggy. So
yeah, and I'm so glad my father was a sailor was not 0, because at least 5 minutes. So thank you.
All right, guys. Do you want me to keep these up, or do you want me to take them down and let you get back to your slide deck?
Take it down.
Okay, thanks.
Oops. So, all right. Yeah, so just like Justin talked about with microservices, breaking out things into highly specialized concepts allows for some flexibility. So, let's kind of talk about Kubernetes primitives and how Kubernetes was designed, to sort of take those components and build on top of each other. So starting from the bottom, when we talk about a container, we're talking about a Linux container popularized by Docker, and that typically represents an application. Going up a level, we are talking about pods, which is really just a group of containers that are sharing some network and storage. Next, you get to the deployment, which is really descriptive of what you are trying to run. You're describing the shape of what your application would look like. And then you're handing that off to Kubernetes, and you're letting Kubernetes get the application into that state. So you've described that you want it to run, in number of instances of my application. Kubernetes says, great, let's do that. And then last, we've got this concept of a service, which is really just an addressable abstraction on top of many pods. So example, you can refer to service A throughout the cluster, and no matter how many pods you have running, you can always get to an instance of them. There are typically different load balancing strategies to get to your downstream pods and containers, but you let Kubernetes handle that. So how you design things matters, and Kubernetes was designed to support running production grade workloads. Next slide. So, what are some of the characteristics of Kubernetes, and what makes it so well equipped to handle production workloads? So first of all, Kubernetes is composable and extendable. The Kubernetes primitives provide the ability to extend functionality into your system, either at a node level through something called a daemon set, or a container level through a sidecar container. So first, let's sort of dive into the daemon sets. When you deploy an application, and let's say your application starts to scale, right? Because you have hit some threshold that requires your application to scale up. When that crosses the threshold of having to go onto another node, and what we don't want to have to do is say, wait, hold on, I need to go deploy the log aggregation tool onto that node as well, so that I can start collecting logs and metrics and ship that out to my logging tool. So what a daemon set does is it'll actually deploy that onto that node when it's first started, so that you get that functionality included next to your deployed application. So what about sidecars? So sidecars are a similar concept at the container level, right? So when we talk about a sidecar container, what we're really talking about is a container that sits next to your existing application that provides additional functionality to that application. So if we think about a lot of legacy applications that maybe were built before it was really thought that, hey, I need to include some mutual TLS into my application logic. When you pull that application into Kubernetes, you want to start to pull in some of these best practices as well. And you could either go rewrite your application to know about mutual TLS or load balancing, caching, like security, or what you can do is set it next to a sidecar that can enrich your application with this functionality. So a second characteristic of Kubernetes is fault tolerance. And simply put, failure will happen. As Justin mentioned before, you will have some network failure at some point, or something will happen. And I think it's important to just go ahead and embrace that, right? So we know failure will happen. So the next thing is, how can we recover from that failure? And I think, because Kubernetes has built this into itself as a first-class concept with health checks, what you can have happen is Kubernetes will see that a container is no longer healthy, and it will kill that container and restart a new container. And that's all done automatically for you. So, if you've ever been part of a prolonged outage where, the last thing the engineer, kind of says is, and then I just restarted everything and it all worked. Well, you get that for free with Kubernetes. So dynamic. We know life is dynamic, businesses are dynamic. There are peaks and valleys of usage of applications, of businesses, right? You have your 9-to-5 businesses that need to handle people on the website from 9 to 5, but then nobody's on it after that. You have the holiday sales weekends. You have the example of an application that supports things on a weekly basis. Really, what we just want to call out is that there needs to be times where we scale up to handle that workload. and then scale back down when it's not really needed. And so Kubernetes has sort of two concepts for scaling. They have the horizontal scaling, which theoretically could be infinite, right? And then, using our business case from a business that's open from 9 to 5, it probably makes sense for them to scale up that compute during the day. And then when nobody's using their application, they should scale down. And then there's a second type of scaling, vertical scaling, which works by observing resource usage in your cluster and making recommendations on how you should tune your application based on that usage. And this can be done manually or automatically. So you can actually tell Kubernetes, hey, thank you for observing this. Go ahead and make this change. We appreciate that. So next, we'll talk about the deployment options and tooling. So we've talked about how Kubernetes architecture facilitates speed and agility. So let's sort of talk about like how we can actually deploy Kubernetes. So I think it's fair to say there's three groupings that we've typically seen throughout our usage of Kubernetes. One is the Kubernetes native. It's less opinionated. It's closer to raw Kubernetes. This means that you have this less vendor lock-in, right? And vendor lock-in is not necessarily a bad thing. It's just this is sort of what the Kubernetes native tooling is providing. The next you have is sort of this cloud managed, and this is for organizations that are maybe all in on a cloud provider, and they want to continue to leverage some of the tooling that they've spent time building out in that cloud provider. This is an example of a SaaS that you can utilize some of the auto scaling or security groups that you've defined in that SaaS and pull them into your Kubernetes. They make that very easy, right? And then the last example is a platform as a service. This is the opinionated offering where they've limited your choices, but really limiting is a bit freeing, right? So you spend less time trying to make your decisions on what I want to do for running my Kubernetes application, and more time really focused on the actual development of your application. And there are pros and cons to each one of these. So looking at sort of the typical tool chain that an organization has, we can start to tell where the maturity is for that digital transformation by going through these circles and determining A, if this circle even exists, and then B, what level of automation or lack thereof is in each circle, right? So starting clockwise, kind of at the ticket tracking, we go through these pieces, addressing each before the next. So for example, if someone doesn't have Git or version control, then they probably don't need to be on Kubernetes just yet. It's also important for us that we at least get some coverage in each circle, which leads me to, it's okay to find a product to buy and kind of get some coverage in this. So, you think that, oh, I have to go now become an expert in all of these tools as well. Well, no, you really don't. You can find a product that maybe if you come to one and you're like, look, we just don't want to become experts at this, that's fine. Like, there are products out there that you can go buy. And in a lot of ways, I would encourage that until you sort of filled out your whole circle, and you can come back and say, maybe this tool isn't giving us everything we need. Maybe we should become experts in it. Maybe we should manage our own, run our own. Maybe it's become too expensive for us to use this tool, and there's an open source tool instead that we should, we really want to get good at and learn. These are all options. So automation is another part of as Justin mentioned earlier, one of the big pieces of DevOps. And so another thing that we start to really try and figure out is how we can automate between each one of these circles, right? And how you can hand off, code that's checked into that next phase, which is, testing, to building, to deploying. And then sort of the last thing I wanted to cover in this section is that microservices will affect every one of these circles, right? With a monolith, you have 1 to 5 repositories, maybe. You have, one deployable artifact, a handful of supporting libraries. Whereas with microservices, you could, for instance, have a repo per service, right? And a deployable artifact per service, right? So it starts to get, it seems like it's starting to build up on and feeling a bit overwhelming. So then kind of coming back to that last slide, you know, we had our left-hand side where it was starting to talk about all of the components and pieces of Kubernetes, right? And all of the tooling that, you know, really is involved for each one of those components on the Kubernetes side. And so what I'm kind of just trying to highlight here is that, you know, we've gone through, and let's just pick some, right? So we've maybe chosen Terraform for infrastructure automation, AWS, Vault for secret and key management, you know, Ansible, AWS EKS, Istio when we needed a service mesh, Datadog. You know, the point being is that you could probably take one or you know, two of these per column and sort of put it together, and what you end up with is this solution. Wow, that's a lot, right? It's a lot of choices. So I think, you know, what I want to do is kind of come back to like, what are we really trying to achieve here, right? So, you know, talking about like considerations and pitfalls, you know, we've decided that microservices give our team the ability to move faster if they can focus on delivering business value and spend less time worrying about running distributed systems. So, you know, what can go wrong? Well, with anything, I mean, learning stuff takes time. There's time to ramp up and get familiar with something, right? You know, you could get lost. I mean, you saw all of those tools that were possible choices, right? You know, again, you could go into this underestimating the complexity of distributed systems. You know, they aren't easy. They take a lot of, you know, like it's hard. A lot of people that we've worked with have tried to boil the ocean, right? Instead of focusing on incremental success. They're like, yeah, we've got a business that's been running for 30 years and we're going to be on Kubernetes next week. That's not going to happen. And, you know, part of that is, yeah, they drop everything just to get onto Kubernetes instead of, you know, focusing on delivering their existing business value, right? Again, that is a problem that we want to try to avoid. So, you know, how do we avoid that, right? I start with getting help. You know, you want to pick the right solution. So, you know, you want to try and figure out, you know, which deployment option is best for you, right? Do you want to focus on, you know, sort of the more opinionated, out of the box solution, more of the PaaS approach, or do you want to sort of dedicate resources and time to understanding some of the Kubernetes native way, right? Where you get a bit more flexibility in the tools that you can bring in and you know, you can work with other vendor agnostic tooling, right? I think it's important to remember that the end goal of Kubernetes is to be able to deliver value faster. So spending 6 to 12 months, you know, just researching the perfect solution is really an anti-pattern in my mind. So with all that said, I'm going to hand it back to Justin.
Yeah, great. So really to bring it all back together, and ending slide before questions, is to bring back the three major areas we had introduced in the solutions section in the first place. So, you know, we talked a little bit about DevOps and about how, you know, there's an importance around organizing your team to be able to achieve a certain set of goals in terms of speed, you know, achieving those things like speed to market and ultimately improvements in the code itself around reliability and those outcomes. But how hopefully the picture has been painted to tie that intrinsically with things like microservices and Kubernetes. There are lots of cases where these do not necessarily one depend on the other. But I think there's an argument to be made that in many cases, and not most, this could be used as a basis for making a decision about how, you know, you'd want to move forward architecturally, organizationally, and common sets of tools and patterns in order to achieve the kind of the outcomes that we want as engineers. I mean, ultimately, the thing that, you know, excites me is to set a particularly large goal. Example would be, you know, I want to release every day. I want to release every change that I make and not be terrified to death. And what is it like? You know, what do I need to be able to do that? And this is a picture that can achieve that. There's many organizations doing it, and then in a lot of cases, it can seem like those organizations are, you know, it can be easy to say, well, you know, it requires too many engineers or too much firepower. We're just not mature enough, et cetera, et cetera. But I think the community has moved to a point where there's so much available that is no longer really true. I think like DevOps is becoming really become just a de facto way to do software development. We all everyone wants to achieve that in some way or another, even if you have something in the form of DevOps and not called by it. You know, where we want to get, I think require some of these tools and patterns. And so hopefully, you know, really in conclusion, that we've you know, created a case that you can take and consider applying to your particular organization, particular nuggets in terms of maybe some tools you would want to consider, patterns about why you might want to consider doing things these way. And, you know, hopefully we've given you something to think on. And really, that's the end of the presentation. If there's any questions about the slides, our experiences specifically, anything really, we're really ready to take them.
Really about your experience as a son of a sailor. So no.
Wow. Yeah.
Yeah. Okay. Well, yeah, we've gotten a ton of questions in so far, so we won't go down that route. But let's go ahead and dive right on in. There's time, guys. If you have a question, please go ahead and use your GoToWebinar control panel and submit it, and we'll try to get to as many as we can. Here's the first one. What will be the base by which decompose monolithic to microservices? Is there any recommendations, or does it depend on each use case or requirements?
So I think I missed the first few, but what is the means by which to decompose a monolith?
What will be the base? I mean, at what point do you decide to decompose monolithic to microservices?
Yeah, that's a good question. Because the monolith itself isn't necessarily a problem. And if I was really, you know, in a lot of cases, I would still even choose some sort of monolith if I was trying to do something particularly quickly in certain situations. But ultimately, there's two different questions. One would be how to decompose and when to choose to decompose. I think the how is a little, in some ways, a little easier, because there's going to be parts of the application, but particularly the engineering team will know this from experience for the particular application you're working on, that are just points of bottlenecks. And there's two going to be points of the application where with a little thought you could extract that out and are really ultimately independent. I mean, an example of a case we've worked on was an application that produced, at the end of the day, produced a bunch of invoices, many thousands of invoices that are going to be sent to customers and all sorts of people. And this was part of a monolithic application, and it became, just looking at this process that took many hours, it was a natural process. Well, really, this is just something that takes in some data and produces a PDF and then emails that data out. It seems naturally like a thing that could be decomposed. And as experience working on these particular projects, we knew this thing took forever. And this was an example to begin the journey in order to decompose. Now, at one point, does it even become a microservice if it's now a monolith plus one other service, right? It's really a microservice the moment, I guess, you start to spawn it off. But choosing the point is can be a little bit of a predictive nature. I mean, there's going to be natural bottlenecks to a monolith that can be solved either with pure just raw hardware and money, or maybe with a little ingenuity. But you know, if you're starting to see limitations, particularly on scaling an application itself, and you're already having issues with, well, my particular application, I can't run two copies of it because they would both share the same file system or the same caching or whatever. We haven't even really solved the complex problems of sharing certain parts of the app, and you're starting to hit bottlenecks. Well, then you've hit the point at which you need to start decomposing. And you don't necessarily have to immediately decompose into the monolith. It could look a little more so. They're very similar in terms of, you know, ripping the structure apart at the code level and putting those into separate pieces. Microservices starts to get more involved with intercommunication in the data layer. But you should just plan to remove out those big chunks that just will most naturally seem independent. I mean, so, you know, there's an application we worked on for delivering goods from a retailer, and that it decomposed into some obvious cases. And okay, there's customers, well, customer service. There's vehicles, well, vehicle service. There's stores, a store service, and even those could decompose even further. But it can be helpful to actually just think about the domain as the first place, because the data is a big part of it, and your domain is probably the most naturally decomposed thing, at least in terms of verbs, and then you just need to take those verbs and actually extract them. So that would be maybe my hopefully answering the question and my suggestion of a way to go about doing it.
Yeah.
All right, so we have 6 minutes to the top of the hour. I think we have time for one more question, maybe two. Let's see. Next question. What are the scenarios where you do not consider microservices?
Want to take that again?
Yes. Yeah, it's a good question. There's a degree, you know, it's like I wouldn't necessarily, there's two things. One, I think you need to really be realistic about the ability of your particular development team. If you struggle to produce a monolith that functions well, you're going to struggle to produce microservices that function well. Now, you know, where do you begin to go about solving that problem can be a little tricky. I mean, it could be a personal issue, it could be an organizational issue. I've seen there could be good people within an organization that just are too tightly micromanaged to really explore the ability to design something well. I mean, in cases I probably would explicitly not. There's two scenarios. One, if I'm already in an organization that has some sort of microservices platform, I'm going to be more willing to do things like do an MVP or some experimental type of work within that infrastructure because it's already going to be up and running. There's still, if I'm doing something completely wild, maybe I would do something off to the side that's just a monolith to prove it out. And then once I have some concept of what that looks like, and have a little more of my head around, okay, this is the domain, this is what represents the services I might need from it, then I might, you know, the second pass or the first refactor might be in the microservices. So that would be maybe one case. And the other would be, there's a degree to which if you're a small enough team, it can be very hard to manage all the overhead of microservices. Yeah. And where is that line of number of people? We have seen the smallest team I've seen succeed is to be a team of 4, but 4 very experienced engineers, and we're given the complete green light to go do it, right? And the time to do it. But it starts to become much harder at a smaller size and less necessary, right? Because a team that size, there's going to be less internal conflict and development. You know, you might want to focus on other aspects over the microservices side of it. Focus on, you know, that small team should still be doing things like automating well and putting all that into place. That would be my first point of focus before moving into the architecture side.
All right. Well, we're 3 minutes to the top of the hour, so unfortunately that is all the time that we have for question and answer. I know we have a lot of great questions that have come in, so please know that the folks at RTS Labs will be getting a copy of all of the questions that came in. So fear not, if we didn't get to your question, you will get an answer. They'll be more than happy to follow up with you offline. So yeah, so I do want to thank everybody who did submit questions, lots of really, really good ones. Also, quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webcast, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I did note at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. Without further ado, let's go ahead and do that. Our first one today is, sorry, Blake, you're not eligible. So first winner is, let's see, Ben H. Congratulations, Ben. Second winner today is Dean S. Congratulations, Dean. Third winner today is Glenn with 2 D's, or 2 N's and a D. Glenn D. Congratulations, Glenn. And our final winner today is, let's see, William H. Congratulations, William, and we'll be following up with all 4 of you via email to get your gift card over to you. So please check your inbox. If you don't see it in your inbox, please check your spam folder. All right, Justin and Blake, thanks so much for a great presentation. Lots of great information and so many great questions. You guys are going to have your work cut out for you after the webinar today. I could tell. So.
Great, awesome. Thank you so much.
Yeah, thanks.
All right, I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.
Bye.